This video is meant to help for the homework for September 15th and September 18th. We're going to use this in class, but I didn't want to spend time graphing the actual function. So hopefully you're doing this on your own before coming to class. You'll bring this into class so that we can talk about it and not have to worry about graphing it. We're going to talk about tangent. I was going to do cotangent, but decided we probably don't have time for cotangent. We could do tangent, so I'll probably scrap this cotangent out of there. If we wanted to graph cotangent, we could do that pretty quickly, but I'm just going to focus on tangent right here. And we're going to do similar to what we do with sine and cosine, but we need to remember that if we're doing tangent, then in the past, it is opposite over adjacent. We also need to know that tangent can be defined as sine divided by cosine. That's going to be really helpful here. Also, if you have your unit circle, that might be helpful to take out, or a unit circle, so that you can refer to it to actually calculate these values. Now, let's start with, I'm just going to go down the table. So if we want to find tangent, our x value is negative pi over 2, our function is tangent. So we're going to plug in negative pi over 2 into our function. Also, there's plenty of room down here. If you want to work it out down there, that's fine. But I would say like leave a little bit of space here for what we're going to do in class. If I'm at negative pi over 2, so if you think of this as the axis on our unit circle, pi over 2 is here, which means negative pi over 2 is here. Coterminal with 3 pi over 2. So we can do sine of 3 pi over 2 divided by cosine of 3 pi over 2. If we do that, the sine value is negative 1. The cosine value would be 0. And what's happening here is anytime we have something divided by 0, that's going to be undefined. Which is interesting. We need to figure out how to graph that, and we'll get to that in a second. If we do tangent of negative pi over 4, if you want to find the coterminal for that, its coterminal angle would be 7 pi over 4. So if this is positive pi over 4, negative would be in this direction. Excuse me. Ooh. If I look at sine at 7 pi over 4, I'm not going to write like this. I'm just going to write the actual values. Sine at 7 pi over 4 is negative square root of 2 over 2. I'm going to divide that by the cosine, which is square root of 2 over 2. Now, we could, divide, multiply by the reciprocal, all of those things. However, in this case, what we really have is, if I take away the negative, we have something divided by itself. Anytime we have something divided by itself, that's always going to be 1. But because this one is negative, it'll be negative 1. If we plug in 0, at 0, sine is going to be 0. Our cosine is 1. 0 divided by 1 is 0. If you want to pause and do the rest of them, that's fine. I'm going to try and do it quickly. At pi over 4, if I look at pi over 4 on my unit circle, I'm taking the sine value, which is square root of 2 over 2, dividing that by the cosine value, which is square root of 2 over 2. Something divided by itself, that's just going to give us 1. Should probably do this. And we could keep going. Pi over 2, sine is going to be 1, cosine 0. We get another undefined piece here. At pi, it would be 0. You might want to verify just for you, because I'm going a little quicker here, but. And at 2 pi, tangent is going to equal 0. Did most of them. If you want to check pi and 2 pi, make sure I'm doing that right. That might be a good thing. I can make mistakes. You know what I mean? All right, now let's go ahead and plot these. If you need to pause, rewind, ask questions, please do so. Let's plot the ones that we can, and then we'll talk about the undefined. So at negative pi over 4, the function is going to go through negative 1. If this is negative pi over 2, negative pi over 4 would be halfway down to negative 1. Sorry, I already scaled the x and y axis. If you need to pause to scale that, please do so. Here at 0, so again, negative pi over 4 would go halfway down to negative 1. If I plug in 0, my output is 0, so that's going to pass through the origin. Pi over 4, so that would be like halfway between 0 and pi over 2 and 1. Pi and 0. Sorry, pi and 0. All these undefined, 2 pi and 0. Now, if we think about undefined lines, think about slope. Anytime slope was undefined, like if we have a function that, like this is our coordinate plane, if our function was this guy, if it's going straight up and down, that's what we call an undefined line. And so what we're trying to say here is that the function is undefined at these various points. We can denote that. The way we denote that is we're not going to use a solid line. If we used a solid line, that means it would be part of our function. So we can actually use like a dotted line. So I'm going to use a vertical dotted line. And that means our function is undefined here. So it's undefined at negative pi over 2. It's undefined at pi over 2. It's undefined at 3 pi over 2. Here it's undefined at pi over 2, negative pi over 2, 3 pi over 2. It'll also be undefined at negative 3 pi over 2. So we have our undefined lines. Anytime we have an undefined value in terms of our function, we can denote that using in most cases, not always, but here in the tangent function, we can use these undefined lines. Okay, now we had these points here in the middle, the 0, 0, the pi over 4, comma 1, which is there, the negative pi over 4, comma negative 1. And what's happening here is the tangent function, we could continue graphing other points, but what the tangent function does is it takes this shape. It's going to go through 0, 0, it's going to go through this point, and then as it gets closer, as it goes up, it's going to get really, 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 really close to this dotted line, but never touch. Same thing as we go down. It's going to go down through that point, and then it's going to get really, really, really close to, but never touch this dotted line. And that's one cycle, if you will. Okay. Now notice here at pi it goes through 0. And the dot, it looks similar. 0, we have dotted lines on both sides. And what's happening here is this tangent function at pi, if I went either way, like for example, pi over 2 and pi. In between pi over 2 and pi, directly in between is 3 pi over 4. And if I had to take sine divided by cosine of 3 pi over 4, it would be negative 1. Here it would be 1. And so it repeats here. Repeats, interesting. And so it takes this shape. And it's going to basically do the same thing over and over and over again. Even here in the negative direction, this is what our function. And it doesn't have to be exact. But this is what our tangent function looks like. It's weird, it has an odd shape, but that's okay. And we'll see in class on either September 15th or 18th, we'll talk about its key features. Domain, range, amplitude, period. Do they have those things? What are they and how we can define them? Then we'll actually get practice transforming them in class. Bring this to class, ask questions if you have them, and we'll talk briefly about it at the beginning of class on September 15th, September 18th.